Or the food channel. We just, at the beginning of class, for those joining us, hi Sam and whoever else is gone today, or on. We just solved out this example the old school way. The old school way is we have to rewrite it, and to rewrite it we had to multiply and FOIL and then do the power rule. And then it said at the very, very end, great job, none of the multiple choice answers would match.
Oh no.
And the only way to make them match would be to multiply them all out, because they're all going to be in nice factored form. So then I'm having the kids look right now at this top expression and think of the question, if this was a derivative and not an integral, and you were spotlighting, ooh, can I actually do this? I should be able to. And you were spotlighting just the stuff on the inside and ignoring the integral and the dx, pretending like it's not even there. Oh, is this not a thing?
Or you can like zoom into that.
Oh, I know what you're talking about though.
Yeah, it's a good thing if you can get it to work. I just don't know which one it is. It's been too long since I've actually done it. Is it the magnifier?
This is so much easier.
The pointer?
Magnifier, like, you
just have like
it and then like it comes
I
up.
think it's this one.
Yeah.
No, that's annoying. That's not even a good spotlight. That doesn't even work. Can I make it smaller?
Yeah.
This is new. I don't like this one. Okay, hold on. Let's get rid of
No,
this.
you caught it.
Wait, wasn't there
There's a better way, though.
Magnifier one's better.
Misty, if you make a circle with the marker, doesn't it make
It's not a marker, though, but what is it? I make a circle with something.
with I remember that.
Oh, it's a great tool. I just don't know what it is.
We need to call him right now.
We just need to get him back here. That's the long story short. Is it the pointer? No. Oh, maybe it is. Oh, no. I got it. Guys, I got it. Don't worry. Although this guy is now in my way. I don't know how to get rid of him. Well.
There you go.
He's gone. It's the magic pen.
Oh.
I need the magic pen.
I remember that now.
There he is. Okay, all better. Magic pen.
It's a magic pen.
Okay.
Now that I've ruined all the magic, but that's okay. Where's the magic pen?
Oh, there
he is.
It should be on the bottom of the left, yeah? Oh, you mean pull on the top. Yeah,
Oh, there he is.
Yes.
Magic pen. Okay, why was I showing that? Well, here's why. I want you guys to look right here.
Oh no.
I give up.
No, don't give up, Misty. We got this, warriors.
Magic pen.
Is it gonna do that?
Yay! Yeah.
Okay, pretend there was no integral. How would you take the derivative of that? That took way too long.
Rule, then chain rule.
Yes.
Pause rule and then chain rule. Okay, so then pretend that you didn't see the whole thing. Let's say that you just saw, let's say you just saw this guy.
Chain rule.
Chain rule.
Yeah.
And how would chain rule work?
You're divide the outside.
Okay, derivative of the outside, so you look at it as a u squared, right?
Mm-hmm.
So it's going to be 2u times u prime. But wait, are we deriving right now?
No.
We're integrating. So we're looking at this as being the derivative of somebody. And you guys just said we would look at it as u to the power of. So if there could be a way to look at this as the integral of u squared du, couldn't we go back from that? But here's the dilemma. Hold on. Why did I put u squared?
Because it's 5x plus 1 or whatever squared.
It's a u that's been squared.
Okay, but what about the
But what happened to all of this
So you'll
thing?
need the 10x and attach.
Pause. Tyler, take a second.
Please.
If u is equal to 5x squared plus 1, pause. If a power rule had been done, if it's now a square, what was it before?
No.
No, if it's now squared, it had to have been what power to begin with? Cubed. So, I could say it came from 1/3 u cubed, right? Like power rule, u to the third over 3, or 1/3 u cubed. But if it was 1/3 u cubed,
That's just a little ugly.
Then that would be.
how would we take the derivative? 1/3 u cubed, bring down the 3. Good. U squared times u prime. What would u prime have been?
Oh my gosh,
Oh my god.
Can you write it out? Because I'm a little.
That was nice.
I'm a little dunce right now.
if you were to take the derivative of this guy,
Yeah.
1/3 u cubed would be 3 times 1/3, which cancels u squared times u prime.
This one works out real nice.
So, it did work out really nicely. But here's the point. Did I need to worry about the 10x? Not really. But hold on. What was here
du
that made it possible to say, okay, it's just u to the 3/3?
divided by
I
the square
saw
root.
that the u prime was the rest. Now, what do I mean by that? Technically, u prime, if I was to write this super nicely, which I didn't exactly do the notation super perfect because we haven't talked about it yet. Let me go ahead and show you the notation. U prime is 10x. U prime, 10x, right? Okay. How can I rewrite u prime? Du over dx. Because dy dx, right, a derivative. So u prime, I could technically write du over dx. Hey, that's snazzy. I have 10x times what?
Yeah.
So if I multiply dx to the other side, what can I replace 10x dx with? Oh, and that's a nice little integral where I have an expression in terms of the variable and the differentiable. I can just ignore that whole thing and say, yay, let's go. 1/3 u cubed plus c, done. Now, here's the weird thing. How is that legal? Here we go, let's take some notes. It is legal because, and it basically opens up to us the world of integration on the AP, because almost every integral has a u. Almost. Every integral on the AP has a u. The fundamental formulas are super important, and how to do the fundamental things like with trig and with exponentials and logs, etc. The power rules, super important, but they almost always have a u. So here's the goal. The goal is new techniques for integrating complex fractions, not complex as an imaginary, complex as in more complicated. So if you want me to change to complicated, I can. For integrating complicated complex fractions. The idea is that we're having to recall the chain rule because the chain rule was used so much when we were doing differentiation. And it's going to be used so much when we're doing integrals, especially AP practice. So we have to recall the chain rule and say, hey, he was pretty important. And so what I had you guys recall is if you were taking the derivative of an f of g of x, you would need to use the rule f prime of g of x times g prime of x. Remember our other notation for that was the derivative of f of u is f prime of u, derivative of the outside, keep the inside, times u prime. So now we can say, given a function f and its antiderivative capital F, if we are given an integral of f of g of x times g prime dx, or f of u times u prime dx, we can actually ignore, in a sense, realize in a sense, the g prime dx or the u prime dx was all just a part of the chain rule. And we don't need to fully consider, as long as he's there, which he needs to be because I need the u prime in that derivative to make it legal for me to go back. But as long as he's there, I can just consider the rest of the integral when solving for my antiderivative. Don't forget your pussy. So with that, once you have that, I'm technically having you guys go back to the original example. And we'll walk through it how I normally will from here on out whenever we talk about u sub. After we walk through it with u sub, don't worry. We'll go ahead and write some steps about what I do and how I do and why I do it. So that you can get some verbalization, some verbal directives as to how to go through the process. First of all, I'll just show you my method. Sorry, I'm trying to see whether or not to make this a forever card. I don't know why it's not naturally coming to me. It could be 1.
What?
The integral of a chain rule backwards.
No.
Yeah, I don't think I do. We just have to get so good at it that we won't.
Yeah.
We never really made one for, we did make one for chain rule. It's more of a procedure than it is a forever part. So for right now, we're going to leave it off. So here's the idea. We look at this guy and we say, you know what? I think there might have been a U in there to begin with. And plus, I don't want to do all that work and not still have the right answer. So then what we're going to say is, you know what? If there was a U, who would he have been? And we already talked about, okay, if there was a U, who would he have been? 5x squared plus 1. Now we could every time say with a U has to come a U prime. And we could show this every time, and then we could show the notation of du dx equals every time. And then we could show the, let's get du alone every time. But did you guys notice where I skipped to and then I kind of started changing the notation to let you see what was going on? I skipped straight to here. So even though when we were doing derivatives, we talk about u primes, we'd be putting u prime. With integration, I need the du and the dx split up. So instead of writing this whole process every time, u prime is, okay, du dx is, okay, du is, I'm going to skip straight here. And say, okay, the differential of u is equal to u prime times dx. We're going to write that down in our steps on the next page. U prime times dx. Now there are a couple different ways of doing it. Once they get a little bit harder, I'm actually going to write this first, and then I'm going to go backwards. Kind of. And that my next step is going to be, okay, hold on. Every single integral in terms of x, every single integral is going to have the dx. If you didn't notice a second ago, Tyler said, well, this one is actually pretty nice. This one actually works pretty perfectly. Not all of them, though, are going to have the exact u prime where you want it to be. So in order to help us be ready for the harder ones, I'm going to take this expression, I'm going to say, okay, you know what? I know a dx is in my integral, so I'm going to solve for the dx. Because you're always going to have a dx in an integral that you're trying to solve. It might be a dt, it might be something else. I'm going to solve for that differential, whoever he is, because whether or not this matches, I know I can always plug in for the dx. Then I'm going to come on up and say, okay, let's substitute. So I can plug in u for that guy. And I'm going to plug in du over 10x for this guy. And as Tyler said, it's pretty perfect. As Sean said, it's right there. The 10x gets to completely reduce with the expression for u prime in terms of dx. Or I should say, dx in terms of to the expression of dx that came from u prime. That's a better way of putting it. And now we get that integral that you guys saw me write down a second ago, which we could then just integrate to be 1/3 u cubed plus c, which we could then come back and say, hey, let's just plug in u, and u was 5x squared plus 1 plus c. Don't forget your cube. That's the multiple choice answer. But what would you have had to do back here? Figure out he's a perfect cube. Ooh. You would have had to pull out the 1/3. And I think if you pulled out the 1/3 to begin with, then maybe you could have seen that that was a perfect cube. That's 5 cubed, and that's x squared cubed. And that would be one. Anyway, it would be a bit of a problem. Not impossible, but definitely hard.
Oh, yeah, that's so.
And here's the crazy thing is, this might not match up quite as perfectly as we think, because, hold on. What if we were to go ahead and FOIL this out? If we were to do our checking step, because remember you can check every integral by deriving, we would bring down the 3. Well, no. If we were to check the answers matched up, because we're not trying to check that guy, we're trying to check that these two are the same, because we would have solved. You could have derived this and seen if it matched, but that would have been really gross. You could have derived that, that's pretty easy, but you're trying to figure out what's going on. We would have to cube this guy, which, let's see, probably the easiest way to cube him without having to do 2 and then do another one would be Pascal's triangle. It's not 1, 2, 1, it's be 1, 3, 3, 1 for my coefficients. So I'd have 1 times 5x squared cubed plus 3 times 5. You guys remember binomial theorem from last year? Plus 3 times 5x squared to the 1 times 1 squared plus 1 times 1 cubed plus c. Then we would get 125 over 3, if I bring that in, x to the 6. Like, oh, look, it matches! And then we would have the 3 and the 1/3 cancels out. I'd have 25 x to the 4th, like, oh, yay, it matches! And then we'd have the 3 cancel out again, so I'd have just 5x squared, and like, oh, yay, it matches! What's the struggle?
Over 1/3, and then C.
I was wrong? Yeah. Who's that? A constant. Couldn't he get absorbed in that guy? And guess what? 1/3 plus C1 is going to equal C2, or 1/3 plus C2 is going to equal C1. Just because there's a plus C in both doesn't mean it's the exact same plus C.
No.
That could be a C and that could be a D. That could be a 3 and that could be a 47. I don't know. It's just a constant. So guess what? These two get absorbed. So if your answers are ever, if you're ever checking, ever off by a constant, double check that it couldn't have just gotten absorbed in the other guy's C. But, once again, we don't want to solve it like that. We want to solve it like this from now on. That answer. Okay. So, let's walk through the steps of what I just did. In that problem. Some people need the words to think about the process. The first thing I did, I said, ooh, there's an inner function. Let's call him U, which we've practiced a lot with chain rule. Ooh, there's an inner function. Let's call him U. Choose wisely. Don't worry, we'll practice. It's not always super obvious who the U should be. Kind of like tape proofs, it wasn't always obvious which side to choose. Anyway.
Ooh. Are there sides now? There's not sides too. No.
No, there's not two sides, but sometimes there are different quantities that could either be U, if that makes sense. Find du. You guys saw what I meant. You could write the u prime and rearrange it. I just like going straight to du with the u prime times dx. So take u prime equals du dx. So an easier way of saying that is when you're finding du, du will always equal the u prime times dx. Just by a simple rearrangement. The du will always equal the u prime times dx.
It's too long.
What?
It's too long of a word. Anti-derivative.
Oh, dear. Not that bad.
Well, it's pretty long.
Solve for dx like I did, because remember it's not always going to be pretty and perfect like this one was. So solve for dx, because dx will always be there for me to plug in. Substitute, rewrite in terms of u and du. If there are still x's left, this one, it was fine. All the x's were gone. We were legal to solve. If there are still x's left, well, we have to figure out something to get rid of those x's. Once we get a du in our integral, we are not allowed to anti-derive until everything is in terms of u. No x's are allowed to remain, but they could be there for a little bit until we figure out a way to substitute for them. Replace u with its function after you find the antiderivative, and don't forget your plus c. As you guys were writing, does that kind of seem to match what we were doing? Basically, guys, today and tomorrow we're just going to play with u sub. U sub? Yep. It's a way of solving an integral that has a derivative that was taken using chain rule. Does that make sense? So it's not really chain rule backwards per se, it's just looking at it and saying, I think a chain rule was used to find this guy. So maybe u sub will let me look at it in a different light, with a different lens, outside of the box that we were stuck in chapter 4a. which will not just make it easier sometimes, but it will make it possible where it would have been impossible before. As you guys are writing, let me show you a quick one on the board that would have been impossible for us to solve. Ooh, I think it was actually, I showed you how to solve this one. Was on the practice test there was one? You guys help me out. If you had seen something like the integral of sine of 5x,
It's so much quicker.
it would have been impossible to solve using the old-fashioned methods. And here's why. This guy on the board, we were able to foil him and take him with the power rule. His answer was way messier and way grosser. But we were able to do it. Why can't we integrate this guy?
It's trigonometric.
It's trigonometric, and what's true with the 5x?
It's inside.
It's stuck. It's not just sine of x, it's a sine of And so if we wanted to solve this using chapter 4a methods, we would have had to think of, I wonder if there might be a way to split up the sine of 5x to be not sine of 5x anymore. Maybe we could break it down to a 3x and a 2x and use some, like, let's see, sines not with or together, so sine of one, cosine of the other, stay the same. Cosine of one, sine of the other. Let's see. And then maybe we could break this guy down to be cosine squared minus sine squared.
Okay.
Maybe we could make this guy to be
Yeah, but you're still not really
sine
doing
of
any
2x
closer,
plus
are you?
x. We change this guy to be.
You could make a T proof out of this.
Oh yeah, we
instead.
could play with this, right?
This can be one of your test questions.
To see if you could make this solvable without the u sub. That'd be interesting.
No.
We can make this cosine of, let's see, 2x plus x.
No. I
And
don't
then
think
this
there's
could
any-
be 2 sine of x, cosine of x. Do you guys see how this doesn't seem to be making it much more
No.
possible to solve with the old-fashioned stuff?
Keep
Look at all
going.
this multiplication. Look at all these squares. We can't do any of that with the old-fashioned. Now, maybe if you kept going with your composite argument, your sum and difference properties, and kept breaking them apart and multiplying, maybe stuff would cancel out. But I think it's just getting worse and worse and worse, meaning the old-fashioned way does not work for every single possible integral. If you just think u sub, if you just think u sub, what can we say?
Sine of u, du, and then du is going to be what, like,
U would equal the inner function, 5x.
du
is going to equal
dx.
5 dx.
And then just divide
Why
by
do we
5.
solve for dx? Because he's always there to plug into.
Yeah, so
Du over 5. Was the u prime there? No.
No.
But check it. When I go to plug in, even if the u prime's not there, I can plug in my u. I can plug in for dx.
du.
And then as long as there is no variable, isn't this just a constant? And can't all constants just come out? And then isn't this a guy that I can go ahead and solve just using my basic integration rule of the integral of sine of x, or u in this instance is negative cosine of u? And I go back and put my u in and say, oh hey, it was cosine of 5x with a negative 1/5 out there. Go team.
Ah.
Let's go practice some more.
Let's see.
Ooh. Here's another one. Square root. We couldn't have distributed that guy. That'd be so illegal, even though all the pre-cal kids think you can. Anyway, so it's okay. They wouldn't mess this one up because there's a 10. But man, if that was 25, they'd be done for.
Oh, yeah,
you
it's
do that
better
or
than
not?
that's all the
So
time.
great.
We don't need it gray. Lo siento.
Is there
You want it black?
I'm like half blind, I can't see.
Well, that seems like a U.
Is that better?
So could you stop the strings for a word? A U problem?
No,
I get you.
Oh my gosh. The integral of 2
Sarah, you.
You.
I got a point for that one. Who's you?
It's not
Besides Sarah, who's you?
X squared minus 10.
Yeah.
Misty, it's not supposed to be U, du. It's supposed to be U,
I know. It was supposed to be you do you prime. That'd be funny.
That doesn't really work.
You do you prime. That's kind of. Question. Hey, it You do U prime? What? We'll work on it. What is U prime?
2x.
Oh dear. Remember, for U prime, you're just looking at this guy. This guy alone. You're ignoring all that and saying, who is his prime? Oh. Remember? You do U prime. Just take his prime right there. You do U prime times dx. Anyway.
And then dx is equal to du over 2x.
Good. Solve for dx because we always have that guy.
Solve for dx.
Which is going to equal du over 2x. Now some of you are like, look, he's right there. I know it's going to be perfect. Just do it.
Cancel
You're
now.
welcome. So then you go ahead and plug in 2x square root of u. And some of you are going to start getting, let's just make it u to the 1/2, please. Yeah, I agree. U to the 1/2 times du over 2x. Look at the top. When u prime fits exactly, what happens?
Yay.
Everything's canceled out, and all you gotta do is say, hey, it's just a u left. Let's do it right. Integrate. So what's the integral of u to the 1/2 du? Add 1. U to the 3/2 times 2/3 plus c. I'm doing that fast because that's basic. Doesn't mean that you've mastered it, but you've seen it. We're still developing that skill. 2/3 x squared minus 10 to the 3/2 plus c. Dun, 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 dun. Can you still derive it and see if it works? Yes, and it does. Go team, as long as you don't forget u prime. Number 2. Hey, remember that whole T-proofy thing? How I said you have to figure out who you want to make u to be, and it might not always be easy.
U.
What about, okay. Can we like simplify this a little bit? Or
Just take secant.
I don't think you want to. We can't take an x out because remember, x is inside the tangent. It's kind of like if you think about wanting to take an x out of this guy, it's like, can't we just take an x out of the square root?
What's secant tangent?
They'll take him out of
okay,
tangent.
but you know that tangent secant.
There is a property with tangent
How about-
squares and secant
Well, what if
squares.
you set u equal to
Secant tangent is
tangent of x?
Divide.
Is that the?
Well, we don't have it equals. We can't take anybody out of the integral.
Do you do secant x or tangent x?
So what Tyler's seeing is I have somebody cubed, so maybe u is tangent, or I have somebody squared, maybe u is secant, or I could maybe even have tangent squared, secant squared, so u is secant tangent that's been squared with an extra guy. Why on earth would every trig integral need multiple pieces? Whenever there's a u sub? Because if you choose u to be one guy, what's going to come up when you take a du?
Secant.
The other guy.
Oh my dirt. Yeah, okay.
This is the u prime of tangent. So I can make it u cubed, tangent has been cubed, times the secant squared. Wait, we didn't even think about him. Well, we didn't need to because isn't he the prime of tangent?
Does this always work out, or is this like specific?
Well, we have to learn how to choose our u's. Because if you had chosen secant as your u, his du is secant tangent, which we don't really have quite. So then, yeah, Austin's like, oh, there's a u cubed. We got this. It's 1/4 u to the 4th plus c. So 1/4 tangent to the 4th of x. Woo! We got stuff to play with tomorrow. Michael, kids, homework sheet is already online and get started, but believe me, we need to keep on mastering it. Bye, guys.
Do you kind of just do that in your head, like which?
You think about if u is tangent, secant squared. Yeah, let's go. If u is, yeah.
Okay.
You gotta know those derivative rules real well.
Ah, right.
English and be with Beth for a second.